In here, we are going to look at the use substitution or the change of variable method for definite integrals. So, if you're given a function f of gx g prime x dx, now remember this is the composite function, and if a composite function multiplied with the differential of the inside function, and we want to change it to a nicer little integral functions which we are able to solve. But now we have the presence of the limits of integrals. In this scenario, not only make the use substitution to the integrand of the function, but we also make that change to the limits. And that's the only difference between the normal way we were doing indefinite integrals for use substitutions. One key component is that when we are doing substitutions for a definite integral, it is always better to make the changes to the limits also. That way it makes simple to work on the problem as a whole and not going back and making all the changes. Okay, so now let's look at some of these examples. Our first example is to evaluate this integral from -1 to 0 x times x cubed plus 1 squared dx. So hopefully you guys are familiar with what would be my u and how to proceed. Notice that you have x cubed plus 1, and I'm sorry, I think I forgot to write this as an x squared. This has to be x squared, otherwise we won't be able to do it. Okay, so it's x squared times x cubed plus 1 squared dx, guys. So let me write this in a nicer form here. It's -1 to 0 x squared times x cubed plus 1 the whole square dx. The reason is because when you're applying the use substitution, every time you have to a composite function, you multiply the derivative of the inside function. So the derivative of the inside function of this x cubed plus 1 is going to be a squaring function. And I think that was what was missing here. Okay, now let's go ahead and start the problem. The u would be is 1 plus x cubed. And what is my du? 3x squared dx. Now remember we have x squared and dx. So it's basically nicer to write it as du over 3 equals x squared dx. So everything kind of resembles. Now remember, that was just to the integrand. Because now we have -1 and 0, we have to make the changes here too. So now these are for the limits. What would be the change to the limits? So remember, this one -1, guys, is for x variable. This is for x. So in a new integral, what we are going to have is for u equals something. U equals something. So let's go back here. When my x is -1, what do you think u would be? It is 1 plus -1 cubed, which is basically a 0. Okay, that means when x is -1, u is 0. On the other hand, when x is 0, what is u? U is 1 plus 0 cubed, which is 1. That's 1. And inside is the same as we have been doing so far. So x squared dx would be now du over 3. And x cubed plus 1 would be now u squared. Now we need to know how to solve these definite integrals. Remember the first fundamental theorem of calculus? So the first thing we have to do is take 1/3 out and then write 0 to 1 u squared du. Notice this is now going to be 1/3, and inside is going to be u cubed over 3, 0 to 1. This one, guys, is the entire derivative f of x. So when we solve this one, it is 1/3 f of 1 minus f of 0, which is what? Which is 1/3. Now replace u by 1, which is again 1 cube over 3 is 1/3 minus 0. So the final answer is 1 over 9. Very, very careful. We do not, repeat, we do not write c here. Constant of integration is not written when we have definite integrals. Okay, that's the most important part, guys. Now let's move on to the next example. Here we are going to evaluate the integral 1 to 5, and the integrand is a rational function with the square root in the denominator. Okay. Okay, so this one, have I missed a problem? It seems I have missed one. Oh, sorry, I missed somebody. Yes, I missed a certain problem. Okay, so here we're going to do, before we do the other 1 to 5, I want to try this one. This is much more simpler than the one I just showed. So let's look at this evaluate the integral. 1 to 2, 3x squared, square root of x cubed plus 1 dx. So clearly this one is the key. This is going to be it's the composite function. Inside is x cubed, outside is a square root. So we're going to take the u to be x cubed plus 1. Du would be 3x squared dx. Now this time it's much more easy because 3 is present, x squared is present, dx is present. Pretty simple. Now remember the limits. This one, guys, is x equals 1. This is x equals 2. We have to change the limits also. Now that limits would be for the variable u, remember. So original problem when it was the variable x, when x was 1, what was my u? U was 1 cubed plus 1, which is 2. When my x is 2, what is my u? My u is going to be 2 cubed plus 1, which is a 9. Okay, now let's make the changes. So this problem now is going to be totally in the u variable. 2 to 9. 3x squared dx is du. X cubed plus 1 is u. Now it is to the power half. It's square root of u. So once again, I'm going to write it in a nicer form in terms of the exponentials. And now we apply the first fundamental theorem of calculus, or the fundamental theorem. So this is going to be u, 3/2 over 3/2, and then our square brackets, 2 to 9. Remember, the inside of the square brackets is the entire derivative, capital F of x, and we're now going to solve f of 9 minus f of 2. Okay, just a nicer little way of looking at this one. I can write this one as equal to this would be 2/3 u 3/2. Sorry. Then 2 to 9. Okay, so F9 now. So it's 2/3 u, that is 9, 3/2 minus 2/3 2 3/2. Okay, now this one you're going to have an, so I can write this as 2/3 common here. 9 3/2 is going to be what, guys? So 9 3/2 is going to be 27 because it is to the power 3. So it's 9, the 3 squared, so it's 27 Now using our calculators, we can write 2 to the power 1.5, that's 2.82 roughly, and final answer would be roughly 16.2, 12 say. Okay, now let's look at another kind of problem. Here we have x and the square root of 2x minus 1 dx. Till now we were able to see problems where the inside function, the differential of the inside function was present. But here we don't see it. So here's a little trick, guys, we are going to work with. And the trick is we are now going to take some algebraic techniques would be taken here. So I'm going to say let my u be equal to square root 2x minus 1. Okay? So what is my du here? My du will be 2x minus 1. So it's a chain rule, guys. Remember here. You're going to first apply the chain rule to this problem. It's going to be half 2x minus 1 to the power negative half times the differential of 2x minus 1, which is a 2. And then dx, what do we get here? Which is half, this 2 and a half, they cancel out here. So we have 1 over square root 2x minus 1 dx. Okay? Now, so we have got this part over here, 1 over square root 2x minus 1 dx. So when I'm going to make the changes here, remember, I'm not going to do anything at this point to the limits, but whatever I've given. So I have dx over this is du. But I'm left with an x. I have to make the changes to the x also. And at this point, this is x equals 1 and x equals 5. So in order to make the x here, I go back to my u substitution, which was given here. From here, I'm going to do some algebra and get some manipulation. So what is this u going to be? So let's get here the stuff. So here u is square root of 2x minus 1, or u squared equals 2x minus 1, or u squared plus 1 equals 2x, or u squared plus 1 over 2 equals x. So now I can make the change of this x into totally a u. Okay, so when we do this one, what do we notice? We have square root u squared plus 1 over 2 du. We also have to do, remember, the limits, the changes in the limits. Okay, let's work on the limits here. So when x is 1, what is my u? It's square root of 2 times 1 minus 1, which is basically a 1. So this u is a 1. Now when my x is 5, my u is square root 2 times 5 minus 1, which is square root of 9, which is a 3. So 1, 2, 3. U is a 3. Now this we can easily solve. I can take the half out. Integral from 1 to 3 u squared plus 1 du. Now here's the fundamental theorem of calculus. We're going to apply that. Half outside, u cube over u plus u cube over 3, whatever, yeah. 1, 2, 3. Now remember, this is your f of u. And you're going to have half outside f of 3 minus f of 1. Now it's just plugging and solving this part. So it's equal to half, as I said, f of 3 minus f of 1, which is half. Now what is f of 3? It's 3 cubed over 3 plus 3. And this is one expression because there are two terms in this f of u minus 1 over 3, 1 cubed plus 1 over 3 plus 1. Okay, which is half. So that 3 cancels out. It is a 9 plus 3 a 12. And then it is minus 1/3 plus 1. And when you do the math over here, the total math equals 16 over 3. So this expression, guys, integral from 1 to 5 x over 2x minus 1 dx is now equal to 16/3. So this, guys, is 16 over 3. Okay, so we're going to do one more example of trigonometric functions. Okay, with definite integrals. Now, the first thing we're going to do is we're going to write this as 0 to pi, because there are two functions and we can separate them, making our life simple. Because this one is easy, the next one requires a little work. Plus 0 to pi cosine 2x dx. I'm going to first do the 0 to pi sine x dx, and then we work there. Now remember, sine x is what? Integral of sine x is what? Negative cosine x from 0 to pi. Now this, remember, is your function f of x. So I don't have to do any change of variables here. We'll have to do it on the second part though. So this one is f of pi minus f of 0. So minus cosine of pi minus of minus cosine 0. Now we all know cosine pi is minus 1. So minus of a minus 1 is 1. And minus with the minus is a positive, and cosine 0 is 1. So here the answer is making to be 2. Now let's look at this part, the second integral. 0 to pi cosine 2x. Here we will need some change of variables. So I'm going to do the part here, 0 to pi cosine 2x dx. Notice this is not the normal cosine x. It has a 2 in the front. So what does that mean? We will make the change. We'll do the u substitution. We will say u to be 2x and du to be 2 dx, and du over 2 is dx. Okay. Now we have to do the limits of the... So when my x is 0, what is my u? Awesome, 0. But when my x is pi, my u, remember, is 2 times x is 2 pi. So we have made all the changes of this x variable to the u. So now here, what do we see? This would be now 0 to 2 pi cosine u du over 2. So half comes out. What do we have? Sine of u 0 to 2 pi. Plugging in by the fundamental theorem of calculus, this is sine of 2u pi minus sine of 0. Now we all know that sine of 2 pi and sine of 0 are 0. So basically this whole part is a 0. So this second integral of 0 to pi cosine 2x is simply a 0. So the final answer is a 2. Okay. Now, I would like you guys to practice on these problems. So these problems are definite integrals with u substitution. Thank you.